Welcome. In this lesson, we're going to introduce the idea of an array list in Java. So let's get started. We've got two learning goals for today. The first is that you can create an array list and explain how it differs from an array. And the second is that you should be able to use array list methods, including add, remove, set, and get, to solve problems. Array lists are designed to hold a list of information much like an array. So a really valid question to ask is, why do we actually need an array list? And the reason is that arrays have one significant disadvantage, which is the fact that they can't change size. So if we've made an array like, say, A1 on your screen, and it turns out that that array is too small, we have some steps that we need to take to make it bigger. The first thing that we have to do is make a new larger array, and you can see that is A2. And then we need to copy all of the elements from the old array to the new array. And that ends up being a lot of steps. And so it's really inconvenient to do that. And there are certain problems where we don't know how many elements we need. And so an array list is going to provide a way to have an array type thing that can grow and shrink without the inconvenience of having to continually remake and copy elements. The big takeaway is that array lists are like arrays, but unlike arrays, they can grow and shrink as needed. Here we see an example of a line of code that actually creates a Java array list. So it looks really complicated, but actually it's pretty straightforward. So first we see the class name ArrayList, and we know that when we want to make any variable, the first thing we do is specify what type of variable. Is it an int? Is it a double? Is it a string? In this case, we're making an ArrayList object. Now the next thing, with the little brackets and the word string, that looks a little bit confusing, but unlike other data types, array lists give us the ability to specify when we're making our array list what sort of information it will hold. And in this case, I'm saying that I want my array list to hold strings. Now the name of my array list is list. Of course, that can be whatever you want. And one last note about using the ArrayList class is it does require an import statement, which is java.util.ArrayList. So in summary, I am making an array list of strings called list, and I'm assigning it to a new array list of strings, and then you can see the empty parentheses at the end, which, as we know from writing classes, calls the constructor for the ArrayList class. Before we go any further, you need to understand one key important fact, and that is that array lists, the way they're built, they can only hold objects. So you can make an array list of strings, but you can't make an array list of ints, doubles, chars, booleans, or any other of the primitive types. This may seem like a pretty significant drawback to using array lists, but if you remember from a few units ago, we learned about the Java wrapper classes. And these wrapper classes exist because there are situations like this one where we might want to use a primitive, but Java is going to require us to use an object. And so remember that for these wrapper classes, there's one for every primitive. So for the primitive int, we have the wrapper class integer, and the same for double, char, and boolean. And fortunately, Java makes these wrapper classes really simple to use. So even though there is this drawback or restriction to using an array list, it's not really much of a restriction at all. Just as a reminder from what we learned before, here's an example of using a wrapper class. So notice on the first line of the code, I create a primitive int x equals 5, and we can see over on the right how that is stored in the computer's memory. Now, if I write a very similar line of code, but I replace int with integer, so in this case, integer y equals 3, you will see that over in the computer's memory, it does hold a 3, but it is stored as an object, as is required by an array list. Now, the beautiful thing about wrapper classes is that you can treat them just like they were primitives. For example, I can say println x plus y, which will add the 5 and the 3 together and output 8, even though x and y are totally different types, right? One's an int, one's an integer, but Java just has it built in to be able to take care of that and handle it. So again, I don't really have to worry or think too hard about it. Now that we know a little bit about array lists, let's take a look at some examples. So on the left, I've got some code, and in the first line of code, I create an array list of integers called list. Notice that I do use the wrapper type integer because array lists cannot hold primitives, so if you actually put the word int there, it would throw an error. Then I assign my array list to a new array list of integers. The only other thing I do is I print line the list. Now, it's important to know that when you make an array list, it starts out empty. So when we do an array, typically we specify a size, right? How many elements we want. But that's not the case with an array list. They are indeed empty when they start. And so when I print line my list, it just prints an empty set of brackets. It's also just good to know that the ArrayList class does have a toString method. So when I say print line my list, it is going to print it out formatted as a comma separated list with a couple of brackets, and you'll see that more as we go forward. Next, let's talk about the add method. And the add method lets me put things in my array list because remember, they start empty. So I've got my array list that I've created up at the top. That's the same as it was on the previous slide. But this time I've added a couple of lines of code where I say list.add and then I give it a value. So list.add 10 and list.add 15. And so what this will do is it will add these numbers to the end of the array list, 10 first and then 15. So at the end, when I print line my list, it should not be a surprise that what gets displayed are the numbers 10 and 15, which are the values that I added to the list. It turns out that there's also a second version of the add method that allows you to add at a specific index. In the case of the code I've got right here, we're going to insert the number 5, and we're going to insert it at index 1. So if you look at where my list is right now, I've got the 10 at index 0, and I've got the 15 at index 1. What I want is I want the 5 to be at index 1. And so notice what happens. It inserts the 5 at index 1, and it slides the existing values down to make room for what we are adding. Not only can array lists grow by adding things to them, we can also remove things and cause the array list to shrink using, not surprisingly, the remove method. And so the remove method is very simple to use. In this case, I'm saying go to my list and remove the element at index 1. And so what that will do is that will go to index 1, and that's going to remove, currently there's a 5 there, and when we print line the list, we can see the output has that 5 removed. Probably one of the toughest things to get used to with array lists is how to access the individual elements. With an array, we're used to doing that just with the brackets. Like for example, if I was to say list bracket 1, that would allow me to access the second element of an array. But unfortunately, it doesn't work that way with array lists. So if you want to access an element, you have to use the .get method. And so here I print line list.get1. I'm basically saying print line the element at index 1. The element at index 1 is 15, and so it's pretty apparent that this is going to print line the number 15. If you want to make a change to an element in an array list, you need to use the set method. So get will get you access to a method, set allows you to change it. And the set method takes two parameters. The first is the location or the index that I want to change, and the second is what I want to change it to. So in this case, I'm saying that I want to set the element at index 1 to 50, and of course, after I do that, we can see that what used to be at index 115 has now been changed to 50 because of the call to the set method. Set and get seem pretty obvious to use on the surface, but actually they can be kind of tricky, particularly when you have to combine them together. So as a little understanding check, I'd like you to come up with the code to double the value of the element at index 0. So right now our array list at index 0 holds a 10. I would like to hold it to hold a 20. However, I want you to write the code in such a way as it would work no matter what value was at index 0. I want to double it. In other words, I don't just want you to set element 0 to 20. I want you to set it to double what it was before. So pause the video, try it out, Hint, you're going to need both a set and a get, and when you're ready, unpause the video and we'll check your answer. On the left, you can see my solution to this problem. Remember, the goal was to take the element at index 0 and double it. So I've done two things. First, I've done a set, and set means make a change, and you can see that I'm trying to set index 0. And then what goes after the 0 is what I want to set it to. And what I want to set it to is 2 times whatever is already at index 0. And remember, if I want to access what's at index 0, I have to use a dot get. So again, I'm setting index 0 to whatever is at index 0 times 2. Let's do one more problem. So for this one, I've got an empty list, and I've done a series of adds and removes. At the end, I print on the list. This one has at least one thing in it that's kind of tricky. So pause the video, give it a try, and see if you can figure out what it's going to print. When you're ready, unpause the video, and we'll take a look at the answer. To see the answer to this, let's go through it step by step. So starting with an empty array list, we add a 2, then we add a 4, so pretty obvious. The third add uses the overloaded method to add at an index. And this one says that we're going to add a 6 at index 2. Well, here's index 0, here's index 1. So we're really saying add it at the end, and we get 2, 4, 6. Now the next thing is remove. We have 2 of them, and the first remove says remove index 0. Index 0 is our 2, and we can see that the line of code does indeed remove the 2, leaving us with just 4, 6. Now, the second remove is interesting, and I wouldn't be surprised if some of you thought that when we removed index 1, we were going to remove the 4, because the 4 used to be at index 1. But when we delete, the list shrinks, and so when we're removing from our list the index 1 here, we're actually removing from this list 4, 6. And index 1 now is the 6. Now, 6 used to be at index 2, but that's before we deleted. And so when we do that final deletion, final removal, we end up with just a 4 remaining. Now that you've watched this lesson, you should be able to create an array list and explain how it differs from an array. You should also be able to use the ArrayList methods add, remove, set, and get, and hopefully we'll be able to use those to solve some problems.